Morning, sir.
Good morning. Okay.
Morning, sir.
Morning.
Good morning, sir.
Good morning. Okay.
Good morning, sir.
Good morning. All right. So what we have discussed in last class, do you have any doubt in that? Huh? No doubt, I think. So if you have no doubt, then we would like to proceed further. Okay, we would like to proceed further. So these two people are Ananya and Darshana joining. Okay, so if we want to proceed further, if we have no doubt in the previous lecture, then we have to see where from shall I start to draw this butterfly diagram. Regarding that, what I am seeing here, that I am given that x of n will be given. So x of n will be given means x0, x4, x2, x5, these are known things. So once we know this x0, x4 and all this, then I can calculate G2 as well as G1. So first of all, to draw the butterfly diagram, what I require that, hello?
Yes, sir.
Hello, listening?
Yes, sir. Shona.
হ্যাঁ
Yes,
স্যার
sir.
তখন শোনা যাচ্ছে না
শোনা যাচ্ছে না মাঝে মাঝে? দেখতে পাচ্ছ তোমার স্ক্রিনটা? স্ক্রিনটা দেখতে পাচ্ছ?
হ্যাঁ স্যার,
হ্যাঁ
হ্যাঁ স্যার দেখতে পাচ্ছি।
Yes, sir.
হ্যাঁ এবার দেখা যাচ্ছে
So what I am seeing that the G1 and G2, they are the function of x. All right. Since they are the function of x, then if you
পিডিএফটা
know,
দেখা যাচ্ছে না।
দেখা যাচ্ছে না?
না,
শেয়ার বন্ধ হয়ে গেছে স্যার
শেয়ারটা বন্ধ হয়ে গেছে?
স্ক্রিনটা দেখা যাচ্ছে না
শেয়ার বন্ধ হয়ে গেছে
এবার
হ্যাঁ স্টার্ট হচ্ছে
হ্যাঁ স্যার দেখা যাচ্ছে।
দেখা যাচ্ছে।
ঠিক আছে
Now what
Sir,
I am,
কেয়া মেসেজ করছে কেয়াকে অ্যালাউ করার জন্য ক্লাসে।
প্রিয়া
কেয়া
কে কে allow করা হয়নি? হয়ে গেছে হয়ে গেছে হয়ে গেছে
হয়ে গেছে।
হয়ে গেছে হ্যাঁ। নুপুর also
গুড মর্নিং স্যার
good morning. Okay, last class কোনো ডাউট নাই তো? Last class? I hope
হ্যাঁ দেখো
last class কোনো doubt নাই. So if you have no doubt in last class, then we would like to proceed further. Now what I am discussing today, that is That is, we are discussing DIF FFT and how to draw this using butterfly diagram. Now, to draw the butterfly diagram, we have to see that number of stages for n equal to 8. For n equal to 8, number of stages will be 2 to the power 3. 3 stages will be there. So 3 stages will be there. Then first stage output are G1, G1 and G2, right? G1 0 to 3 and G2 0 to 3. This will be the output of the first stage. So G1, G2 you can calculate because you know x0, x4 and all this thing because x of n is given. If x of n is given, then I can compute G1 and G2. This is the first stage. And second stage output will be D1 on 0, 1, D1 to 0, D1 to 1, D2 1 0, D2 1 1, D2 to n, I mean D2 to 0 and D2 to 1. They are the function of G1, G2. If I compute in the first stage G1 and G2, then second stage I can compute D1 1 2, D2 2. All 8 value I can compute. So first stage output will be G1 and G2. Second stage output will be D1 1 2, D2 2 1. Okay, so second stage will be there. And third stage, of course, your output will be x0. Your third stage output will be x0, x1, and all this. Output will be x0, x4, x2, x6. They are the output of the third stage. So these are the 3 stages of computation. So if n equal to 8, that could be written as 2 power 3, and 2 power 3 means I can say number of stage will be 3. Okay. Now let us start drawing this butterfly diagram. Now if we look at G1 of 0, so first what I have to do, I have to draw 8 lines. First I have drawn 8 lines. This was 1 line, 2 line, 3 line, 4 line, 5 lines, 6, 7 lines. 7 lines, 8 lines starting with 0. So that 8 lines I have to draw, 8 parallel lines. First thing. Second thing what I have to do, I have to see the expression, how do the G1 and G2 connected with x of 0 and x of 7 up to x of 7. Now if you look at this, G1 of 0 equal to x0 plus x4, x1 plus x5, x2 plus x6, they are the G1. Now let us do that first. Now if you go there, then this will be G10, G10 equal to x0 plus x4. So this is x4 and this is x0, that will be G1 of 0. Similarly, x1 and x5, that will give you G1. Like that, you will get G2 and G3. G2 and G3 will be x2 and x6 and x3 and x7 respectively. With that, you have got G1, G2, G1, G2, G3, G0. All these 4 things you can get. If I look at the expression again, let us come here. Then if you see that they are the relation between this. So if I connect x0 to x4, x1 to x5, x2, x6, and they simply, if we add, I will get G1. Now, while getting G2, I have to get just negative x0 minus x4, G2 0, then x0 minus x4. So now I have to add a negative sign. So x0 minus x4, then you have to multiply W80. Now see, this is multiplication after that x0 minus x4. x0 minus x4, I can write x0 plus minus of x4. So essentially, this subtraction is essentially addition operation. Now, what I'm saying that this multiplication is post, and previously DIT, the multiplication was pre. So in DIF FFT, it is a post multiplication. Then I have to find x0 minus x4 and x1 minus, this will be 1, right? This is not 0, 1. x1 minus x5, x2 minus x6, x3 minus x7, that will be W80, W81, W82, W83. Like that, we can do that. Now let us see what is x4. Now, if you see x4 here, sorry, G20, G20 means this x0, x0, this is minus x4. So G20 will be x0 minus x4 at this point. Then I have multiplied with W80. Similarly, G21, that will be x1 minus x5 here. That will be multiplied, this will be G21, then this will be multiplied by W81. Now, G2 of 2, that will be x2 minus x6 here, that will be multiplied by W82. and G2 of 3, that will be x3 minus x7, that will be here, that will be multiplied by W83. So W80, W81, W82 and W83, they are the post multiplication in DIF-FFT, which was previously in DIT-FFT, they are the pre-multiplication. The multiplication factor was here and then it was minus and all. But in case of DIF-FFT, W80, W81, they are the post multiplication. This is one difference between DIT-FFT and DIF-FFT. Right. So DIT-FFT and DIF-FFT, this is the one difference, that multiplication was a pre-multiplication in case of DIT-FFT and multiplication is a post-multiplication in case of DIF-FFT. I hope this is clear.
পোস্ট কেন হচ্ছে এখানে?
হ্যাঁ
স্যার
হ্যাঁ, তো আমরা যখন লিখছি এক্সপ্রেশনটা তখন তো সাথেই লিখছি, তাহলে এখানে পোস্ট মাল্টিপ্লিকেশন কেন হচ্ছে?
মানে অ্যাডিশনের পর মাল্টিপ্লিকেশন,
অ্যাডিশনের পরে মাল্টিপ্লিকেশন, অ্যাডিশনের পরে মাল্টিপ্লিকেশন। দিস ইজ বিকজ তোমরা এক্সপ্রেশনটা যখন বার করেছিলাম তখন সেভাবে আছে, দেখবে এক্সপ্রেশনটা যেভাবে আছে সেটাই তো ইমপ্লিমেন্ট করছি, ঠিক আছে? এক্সপ্রেশনটা যেভাবে এসছে আমরা সেভাবে এটা ইমপ্লিমেন্ট করছি, ঠিক আছে? সেই কারণে এটা এরকম হবে, তো ওখানে এক্সপ্রেশনটা যেভাবে এসছে সেভাবে ইমপ্লিমেন্ট করেছি, ঠিক আছে? সেইভাবে ইমপ্লিমেন্টেশনটা হবে যেভাবে এক্সপ্রেশনটা ডিরাইভ হয়েছে। ওকে, নাও
স্যার
হ্যাঁ
স্যার
বলো।
তো বলছে এই যে G21 ইকুয়াল টু তো ধরুন x1 মাইনাস x5 পুরোটা মাল্টিপ্লাইড বাই W81, তাহলে আপনি আগে G21 লিখেছেন তারপরে
হ্যাঁ বলো, বলো আরেকবার বলো। G21 টা কি?
G21 ইকুয়াল টু x1 মাইনাস x5 W81 তো।
হ্যাঁ তাই হলো, তাহলে x1 টা এখান থেকে এলো, দাঁড়াও G21 টা দেখি, এটা তোমার G21, তাহলে এখান থেকে আমার x1 টা এলো, G20 এটা G21, হ্যাঁ G21 টা মানে এখানে x1 আছে, তাহলে x1 টা আমার এখানে এলো, x5 থেকে এখানে মাইনাস x5 হয়ে ঢুকলো, তাহলে এখানে হয়ে গেল x1 মাইনাস x5 এই পয়েন্টে এসে গেল, তারপরে মাল্টিপ্লাই করছি W81 দিয়ে।
না G20 টা আগে লিখেছেন না?
G20 টা আগে কেন লিখেছি এইটা?
হ্যাঁ হ্যাঁ
G20 আগে হবে তারপর
মাল্টি,
আরে G20
টা মাল্টিপ্লিকেশনের আগে কেন লিখেছেন ওটা বলছি।
হ্যাঁ ওটা বলছি, তো ধরুন অ্যাডিশন করলাম তারপর মাল্টিপ্লিকেশন, তারপরে তো আমি G20 টা পাচ্ছি বা G21 টা পাচ্ছি, তাহলে আগে লিখেছেন মানে W80 W81 এর আগে লিখেছেন কেন?
W80 W81 টা এই G2 আর এটা একই সঙ্গে, এটা অ্যাকচুয়ালি এখানে লিখলেই ভালো হতো, ঠিকই বলেছো, মানে
আগেটাই লিখো ওটা।
হ্যাঁ আগে লিখলেই ভালো হতো, ঠিক
ওটাই বলছি।
হ্যাঁ কিন্তু আলটিমেটলি হোয়াট মাই পয়েন্ট ইজ G20 মাল্টিপ্লাইড বাই W80, তো G20 এই জায়গাটাই যদি ধরো সেখানে হচ্ছে মাইনাস পর্যন্ত, তারপরে এইটা মাল্টিপ্লাই গেল এইটা, তার মানে এই জায়গাটায় হচ্ছে G20 মাল্টিপ্লাইড বাই W80, তার মানে আমি যদি এখানে G20, হ্যাঁ ঠিক আছে, তার মানে কি এই স্ট্রেংথটা তো আর একই, তার মানে W80 আর G20 দে আর মাল্টিপ্লাইড ইন দিস লাইন, দ্যাট ইজ দ্য ইমপ্লিকেশন। তো G20 টা যদি আমি এখানেও লিখি আর এখানে লিখি ব্যাপারটা তো একই, কারণ এরপরে তো আর কোনো মাল্টিপ্লিকেশন ফ্যাক্টর নেই, তার মানে এই G20 যেখানে শেষ হলো তারপর থেকে যেখানেই আমি যাব সব লাইনটাতেই W80 G20 মাল্টিপ্লিকেশন। এইবার হ্যাঁ যদি তোমরা বলো যে G20 তেই মাল্টিপ্লিকেশনটা হয়ে আছে, তাহলে ওইটা তাহলে আগে লেখাটাই ঠিক হবে, ঠিক বলেছো, একদম কারেক্ট।
ওটা তো সাইডে, তাহলে তো আমরা
হ্যাঁ ঠিক আছে, তাহলে ওটা মাল্টিপ্লিকেশন না, আসলে আমি যেটা এখানে মিন করার চেষ্টা করেছি যে পোস্ট মাল্টিপ্লিকেশন বলে আমি পরে লিখেছি, কিন্তু ওটা আগে লেখাও যাবে, ঠিক আছে? কিন্তু যেটা ব্যাপার হলো যে x0 মাইনাস x4 যেখানে শেষ হচ্ছে তারপরে W80 যেখানে আসছে তার মাঝে তো আর কোনো মাল্টিপ্লিকেশন নেই, তার মানে ওই পয়েন্ট অনওয়ার্ড সবটাই G20 মাল্টিপ্লাইড বাই W80। তো যেহেতু G20 তে W80 টা আছে, তাহলে G20 টা W80 পরে লিখে দেওয়াটাই ঠিক হবে, কারেক্ট? ওকে ঠিক আছে, তাহলে এটা পরে লিখে দেবে, কারেক্ট? ওকে,
ওখানে একটা পয়েন্ট করে দিলেই হবে যে ওখানে আসছে অ্যাডিশনটা হলো দেন
মাল্টিপ্লিকেশন, মানে ওইখানে অ্যারোটা দিয়ে দিলে ওইদিকে হয়ে যাবে, ঠিক আছে?
হ্যাঁ
করে দেবো। নেক্সট নাও, তাহলে এইখানে what we have got লাইক এইখানে আমরা তাহলে G20 W80 এই জায়গাটায় পেয়ে গেলাম, সিমিলারলি G21 W81 এখানে পেয়ে গেলাম, G21 W82 এখানে পেয়ে যাবো, এখানে আমি তাহলে এই আউটপুটটা পেয়ে যাবো G32। মাই পয়েন্ট ইজ that if you look at DIT-FFT এখানে পোস্ট মাল্টিপ্লিকেশন প্রি মাল্টিপ্লিকেশনটা যদি একটু ক্লিয়ারলি বলি, তোমরা যদি এই এক্সপ্রেশনটায় যাও, এটা কোনটা, এটা ডেসিমেশন ইন টাইম, ওকে। এইখানে যদি দেখো পিটার বাটারফ্লাই ডায়াগ্রামটা এখানে নেই কেন? দাঁড়া বলছি, যে জায়গাটা আমি বলতে চাইছি, x0 x1 হলো, x7 হলো v11 v2। নাও এখানে যেটা দেখো, যখন f1 f2 ছিল প্রত্যেকটাতেই মাল্টিপ্লিকেশনটা হয়েছে, তাই না? তোমরা ওইটার বাটারফ্লাই ডায়াগ্রামটা কই?
নিচে নিচে
নিচে আছে। এইখানে দেখো, এইখানে মাল্টিপ্লিকেশনটা যখন v11 of 0 ছিল, v11 of 0, v11 of 1, এখানে v12 of 0। এই দেখো, এই যে wkn টা, এটা উপরেও গেছে নিচেও আসছে, দেখেছো wnn টা, a প্লাস wnn কে a মাইনাস b তারপর wnn কে, তাহলে wnn কে টা আগে মাল্টিপ্লাই এখানে করা হয়েছিল, কারণ এই মাল্টিপ্লিকেশনটা উপরটার সঙ্গে মাল্টিপ্লাই হওয়ার পরে অ্যাড হয়েছে, and that is also applicable for bottom line as well. That means a minus b times 1, মানে wnn কে that is multiplied and added in both cases, right, both the line, but here wnn ke multiplied only in the bottom line, not in the top line. So this is the difference what I want to mean, that why multiplication is post and why multiplication is pre. In case of pre multiplication, top and bottom line both containing the multiplication factor, right, both containing the multiplication factor, but in case of DIF-FFT, only the bottom line containing the multiplication factor, not the top line. That's why this is a post multiplication. See, this every expression there is a multiplication factor, like x0 x1 x2, see, in every expression there is a multiplication factor, right, in every expression, not that only the bottom line, right. In case of DIF-FFT, if you look at this expression, in DIF-FFT, if you look at this expression, then in DIF-FFT, only if you look at where I have summarized all this expression, then previous G1, G2, there is no multiplication because they are the simple addition, right? This multiplication is not there. Multiplication only in G2, but multiplication is not applicable to G1, is not it? That's why this is a, and again, if you look at D10 and D11 or 1, there is no question of multiplication. But multiplication is D1 to 1, D10, 1 to 0, and D12 of 1. There is a multiplication. Similarly, D21 of 0, D21 of, there is no multiplication. It's a simple addition. But D22 of 0 and D22 of 1, there is a multiplication. So multiplication is not applicable to both top and bottom. It is only only bottom lines. Therefore, this multiplication is a post multiplication. Agreed?
Yes.
Right? If we make a pre-multiplication, then this multiplication will go top as well. But at the top, there is no multiplication. Therefore, this is a post multiplication. That is as derived from the expression, what I said earlier. I hope this is now very much clear.
Yes.
Right? Because from this expression, it may seem that W40, if I write here does not make any difference. Of course, that does not make any difference for this a particular expression. But if you multiply, it's a pre-multiplication, then it will be considered in previous case also. Suppose if I give the multiplication sign W80, suppose if I give W80 here, then which means the W80 is going there also. Is not it? So that
Yes.
is not a pre-multiplication mean you have to paste it here, but it is post-multiplication means after addition or subtraction, after subtraction there is a multiplication. That is after subtraction there is a subtraction, which essentially I say addition. After addition there is a multiplication. That is called post-multiplication, right? But if it is a pre-multiplication, then multiplication first, then addition, which was in the DIT50. First multiplication, then addition, that is called pre-multiplication. But first addition, then multiplication, that is called post-multiplication. You have studied this in your data structure? Post-multiplication and pre-multiplication? In data
পোস্ট প্রি একটা ছিল স্যার,
হ্যাঁ
হ্যাঁ ছিল
ছিল
ছিল স্যার একটা পোস্ট প্রি এক্সপ্রেশন একটা ছিল এক্সপ্রেশন।
পোস্ট ছিল তো, তাহলে সেইটা তোমরা করনি বলে সেখানে মনে নেই, তাই না?
না
তাহলে আগে যদি আগে যদি মাল্টিপ্লিকেশন করে তারপরে অ্যাডিশনটা হয় সেটাকে বলে প্রি, আর আগে অ্যাডিশনটা করে তারপরে যদি মাল্টিপ্লিকেশনটা হয় তাহলে আমরা বলি পোস্ট মাল্টিপ্লিকেশন, লাইক দ্যাট। ওকে, ফাইন। So with this I have got here this position. I have G20 W80, I mean G20 rather. So if I write G21, so if I substitute put it here, then I write G21. So at this stage I will get the output of the first stage. My output of the first stage, of course, after multiplication W80, W81, W82 and W83. After that we'll get this. Is it all right?
yes
So far? Fine.
Yeah.
Next thing that I will get here is, suppose say I have to find next, what I have to find? I have to find next D11, right? So D11 0, that will be D11 of 0 plus D11 of 1. So what we have got, D11 of 0, D11 already we have computed. We have to then you have to compute this, right? This expression. I have required this expression. So D11 of 0 equal to G1 of 0 plus G1 of 2. In first stage, I have computed G1 of 0 and G1 of 2. That I have computed in the first stage. Now, once this is computed, then next stage I can add these two, then I will get D11 of 0. Now see, here D11 of 0, D11 of 0. So this is D11 of 0. So G1 of 0 plus G1 of 2. This 2 will get you D11 of 0. And D11 of 1 equal to G1 plus G3. Like that, second stage you will get D11 of 0, D11 of D12 of 0 and D12 of 1. D1, and definitely W4 if you write here, that will be better. So we will write W4 and W2. However, it means that from this line on this line, there is no any other multiplication, but W41 D1 that will be here output. Okay. Now my point is that with this we have got the D1 values, right? That once I know this G1 and G2, G1 and G2, I can compute the value D11 of 0, D11 of 1, D12 of 0, D12 of 1, all this. So G0 minus G2, if you want to write, how it look like? It look like, suppose say, G0, now see G0, G1 of 0, G1 of 0, then this is G1 of this is minus. So this is D12 of 0. So G1 of 0 minus G1 of 2, that multiplied by W4 0. Okay. Similarly, D12 of 1, to see G1 into minus G3 multiplied by W4 1. Okay. Is it all right?
Yeah.
So like that, if I say D12 of 0, that will be G2 of 0, and this will be G2 of 2. Like that, you can calculate all this thing. And in this position, that is G2 of 0, and this will be G2 of 2 minus, that multiplied by W4 0. Like that, from this expression, we can organize this butterfly diagram. And this D1, once you computed, this will give you the second stage of the output. All right. All right.
Yes.
Fine.
Yes.
Now what we have to do, we have to compute. This is the next stage. Next stage, if you want to compute, then you will get suppose something like this one, d1 on of 0. So d1 on of 0, that will be d1 on of 0 plus d1 on of 1. And d1 on of 1 is d1 on of 0 minus d1 on of 1, w20 equal to 1. So what I have to do, once I have got d11 value, small d11, so d1 on of 0 equal to d1 on of 0, d1 on of 1. So this will be d1 on of 0. And here the output will be d1 on of 0 minus d1 on of 1, that is equal to d1 on of 1. Now, if you look at here, d1 on of 0, which I have already computed, equal to x0, and d1 on of 1 equal to x4. So here the output will be x0, next output will be x4. Next, you will be having d12 of 0, d12 of 0, d12 of 0, if you see here, d12 of 0 equal to d21 of 0 plus d21 of 1, and d21 of 1, capital D21 of 1 equal to small d21 of 0 minus small d21 of 1 into w20. Basically, you have to add this and you have to subtract because w20 is equal to 1. Now, if you look at here, so this you have to say here, so d12 of 0 and this is d12 of 1, this come here, and d12 of 1, this come here, this will becomes your d12 of 0, and d12 of 0, that will be equal to x2, which we have already computed, d12 of 0 equal to x2, and d12 of 1 equal to x6. So this is equal to x6. Okay, so x6, then d21 and all these things you can compute accordingly as per the equation. Then you will get x1, x5, x3, x7. Because if you see that this is essentially this, if you look at this one, this is basically d1 on of n, right? d1 on of small d1 on of n. So small d1 on of n is a 2-point signal. The 2-point signal, I have to compute the DFT. So this will give you d1 on of 0 and d1 on of 1. And we have seen that d1 on of 0 and d1 on x0, x4. Similarly, if we compute this output, it will be x0, x4, x2, x6, x1, x5, x3, x7. Now, what does it mean? That output is now in bit reverse order. Output now in bit reverse order.
Yes.
Because x0, next output has to be x1, instead of x1 it will be x4. So output is now in bit reverse order. So another difference between DIT-FFT and DIF-FFT, first difference is in case of DIT, multiplication is pre, and in case of DIF-FFT, multiplication is post. This is the first difference. And second difference is in DIT-FFT, inputs are bit reverse order, output was in normal order, but in case of DIF-FFT, input is normal order, but output is a bit reverse order. This is the two difference. Agreed?
Yes.
So this completes the butterfly diagram of DIF-FFT. And once I have computed the butterfly diagram, then I should be in a position to solve problem using this butterfly diagram. All right.
Yes.
Now next what I have to see. Therefore, if this is in normal order, okay, if this is in normal order, then I can write 2 1 2 1. Then I have written this in normal order. So it's normal order. Then if I compute this, then g1 of 0 equal to x0 plus x4. So x0 plus x4, if you see, this will be 3. Like that. Okay, x0 plus x4, this will be equal to 3. All right. Then this will be x1 plus x4, x1 plus which one? X5. Is not it? X1 plus x5. So this will be equal to 3. Now this, if you see, x2 plus x6, this will be again equal to 3, and this is equal to 3. So this point of the first stage you are having 3. Now second stage output that will be equal to, this is 2, 2, this is minus 1, 2 minus 1, this will be equal to 1 into W80. So this becomes 1, right? Now this stage, if you look at the output, this will be equal to W81, because what is the G21? G21 means at this stage. At this stage, what is the output? This is coming 1, this is 1, and this is 2. So 1 minus 2 is minus 1. And W81, W81 is how much? W81, W81 is how much? E power minus j pi by 4, so 1 by root 2 minus 1 by root 2. So if I multiply by minus 1, so minus 1 by root 2 plus 1 by root 2. All right. Similarly, W2 equal to J, so you can G2 of 2, so that will be equal to, here it is 2 and here it is here it is 1, so 2 minus 1 is 1, 1 multiplied by minus J, W82 equal to minus J, so this will be your minus J. All right, W82, where is W82? This will be minus J. So you will get, this is equal to minus J. All right. Now, if I write G2 of 3, G2 of 3 means again x3, this is minus x7, and this will be multiplied by W83. So at this stage, the value will be 1 by root 2 plus j by root 2. This is because if you look at this, this is 1, this is 1, this is equal to 2, 1 minus 2 equal to minus 1, minus 1 multiplied by W83. W83 is equal minus j by this value. So minus of 1 multiplied by this. So this will be equal to 1 by root 2 minus j by root 2. Is it all right? Is it all right?
Yes.
Fine. So once you got this, then next stage means this stage, if we see, then what is the output of this stage? Output of this stage will be 3, 3, 3, 3, 1, this, and this. So these are the points. This is the output of the first stage. Okay. Now, if we look into the second stage of the output, so D1 on of 0. So this will be 3 and this will be 3. So this will be 6. Similarly, this will be 3 and this will be 3. This will be 6. And this will become, see, this is 3. This is minus 3. This becomes 0. And this is 3. This is become minus 3. So this is become 0, becoming 0, like that. Now, D21 of 0. D21 of 0 means this is after W80 is 1. This is 1. And this is minus j. This is 1 minus j. And this will be G21 of 1. G21 of 1 means this will be this thing, 1 by root 2 plus j by root 2 here. Okay, and this will be coming here, 1 by root 2 plus j by root 2 here. So if you now total out this thing, then this is D21 of 1. This 1 by root 2 plus j by root 2 plus 1 by root 2 j by root 2. So this 1 by root 2 to cancel. So this will be equal to j times 2 by root 2. Okay, j times 2 by root 2. So if you look at this, I have written j times 2 by root 2. Okay. Similarly, if you calculate all these things, like this one, if I see 1, this is equal to minus j, and this is minus 1, this will be 1 plus j, right? And this is equal to this and this. If you look at this, this is also j times 2 by root 2, because this is coming here and this is coming here with sign. With a negative sign means this will be j into 2 by root. This will be equal to, basically, if you add this to here, this is coming here and this is coming here. So if this is negative multiplication added, means this j terms will cancel. So it will be minus of this, right? Minus of 2 by root 2, right? Then if it's multiplied by W4 on minus j, it will be j times 2 by root 2. Agreed?
Yes.
So this is to calculation, if you see it little bit of that this is minus 1 by root 2 plus j by root 2 with a minus sign. Then this is cancel, but j by root 2 with 2 negative sign, that will be equal to, this will be equal to minus and minus 1. So this part will remain. So this will be minus 2 by root 2, real part will there. Then this will be multiplied by minus j. So minus 2 by root 2 multiplied by minus j, it will be j times 2 by root 2. All right. So like that, this calculation is done. Now coming back to this here, final stage of the output. So if you look at this is this, so this will be 6 plus 6 will be 12, and this will be 6 minus 6, that will be equal to 0, right? So this will be, if you look at again here, so this will be again, you will get something like this will be your 0, and this is also 0, this output is 0, and since both the input are 0, this output also will be 0, right? So 3 continuous 0. Then this output, if you see x1 x5, so x1 will be, this is 1 minus j, and this will be minus 1 into j by root 2. So this one I have calculated separately. Let us look into that. 1 minus j plus j by root 2, so it will be 1 plus j 2.4, because 1.414 j minus j, so j 1 plus j 0.414. Similarly, if you look at x5, x5 means here, so this will be 1 minus j here, and this will be j by root 2 into minus 1, so this will be added, so this will be adding to your x5. So if this is adding to your x5, so minus j by root 2, so it will be minus, this will be 1 minus j 2.414. Similarly, x3, if you look at this will be 1 plus j, this will be 1 by 1 plus j, and then this will be j times 2 by root 2. So 1 plus j here and j times 2 by root 2 here. So this will be, see, 1 plus j times 2 by root 2. So 1 plus j 2.414. Now, if you look at x7, if I look here, x7 will be 1 plus j here, then minus of j times 2 by root 2. Then if you look at x7, 1 plus j minus j times 2 by root 2, 1 minus j 0.414. Agreed? This
Yes.
calculation. But what we have got here, that calculation, if I see that we have got here in this, the output will be x0, x4, x2, x6, x1, x5, x3, x7. So I have to organize this thing. Organize these things means I have to write it x0. First I have to write the output of the third stage. Output of the third stage as we have write. Then you have to organize as x0, x1, x2, x3. Then you will get the final output. Then if you compare this output with the previously DIT FFT computation of output, then you will say they are identical. They are identical. For example, if you look at the result of DIT FFT for same problem that I have solved, then if you look at this, I don't know where is the solution here. I think x0, x1 I have solved for that particular problem. Where is the solution? I have solved this problem. Where is the solution of this problem? I have solved this problem, na? One problem.
Yes, নিচে আছে।
হ্যাঁ নিচে কোথায় বলো তো? 2-1 যে প্রবলেম সলভ করেছিলাম,
এরপরে ওটা আলাদা একটা ইয়েতে ছিল, পিডিএফ।
আলাদা পিডিএফ ছিল, এই পিডিএফটা এখানে নেই বোধহয়, না? ওই পিডিএফটা বোধহয় এখানে নেই। So that was in one PDF that I have shown you. Then if you compare that result, so you have the PDF, na? So you compare this result with the previous result, you will see that results will be identical. But while comparing, you have to see one more thing, that is the order you have to see, because you have to again arrange the output in x0, x1 up to x6. Then you compare. Okay, right now I don't have result in this total PDF. So that result you compare with the previous one, it will be the same result. Okay, so I hope if you have any doubt you can ask, otherwise I have hardly 1 minute left. If you have any doubt you can ask. In DIF FFT, any doubt you have? Any doubt in the calculation of this problem? ঠিক আছে স্যার?
দেখতে হবে স্যার।
হ্যাঁ কি হবে? দেখতে
হবে আর একবার
পুরোটা দেখতে হবে, না?
হ্যাঁ
মোটামুটি ক্যালকুলেশনটা বুঝে গেছে তো, যে কোথায় কোথায় কি আছে, কিভাবে কি হচ্ছে?
হ্যাঁ
ঠিক আছে। আচ্ছা, আজকে রেফারেন্স গ্রুপ বলছে, আজকে প্লেসমেন্ট সিজনে কার কার পরীক্ষা আছে?
আচ্ছা স্যার, আমাদের
কজন?
আমার আছে।
আমি আছি।
তুমি কে? নুপুর?
নূপুর।
আর বাকি টোটাল প্লেসমেন্টে যে ইসি2 তে কতজন আছে জানো?
কত 23-24 হবে মনে আছে।
ইসি3 এ জানো, ইসি2 এ কত?
ও 2 এ জানি না, আলাদা করে দেখতে হবে।
দেখতে হবে তো। যা আজকে পরীক্ষা সবাই দেবে, ঠিক আছে? পরীক্ষাটা
আচ্ছা
সবাই দেবে। আর যাদের পরীক্ষা দিতে পারবে না মনে হচ্ছে তারা অন্য কাউকে শেয়ার করে দেবে আইডি, দিয়ে পরীক্ষাটা কিন্তু আজ কমপ্লিট হতে হবে সবার, ঠিক আছে? ঠিক আছে, আজকে এখানে শেষ করছি, এখন আর 1 মিনিট আছে। নেক্সট ক্লাসে আমি কিছু প্রবলেম আরো সলভ করে দেখাবো, প্লাস ইফ ইউ হ্যাভ এনি ডাউট দ্যাট অলসো আই উইল ক্লারিফাই, দেন আফটার দ্যাট আই উইল স্টার্ট ফিল্টার ডিজাইন টেকনিক। এন্ড ফিল্টার ডিজাইন